Hello and welcome everyone to another programming video of me, Florian Rugalla, your host at Beats Basteln. That's how it's pronounced. I'm sometimes asked how it's pronounced. It's pronounced Beats Basteln. Okay, so in this video I'm going to show you how to hack your way together in audio development if you don't know how to actually solve a DSP problem in the proper way, which is a skill that you sometimes need, even though it might sound a little bit whack. But as long as it gets the job done, it's cool. Now let me first introduce you to the problem so that you know what we're going to do in the following. This beat sounds like this. Then I turn the plugin on and then it sounds like this. And now if you know this plugin, then you know that it's a vibrato, and yeah, you could hear it a little bit fluctuating the signal. We could make it even more prominent by choosing the LFO. But that's not the point. The point is that even if without vibrato, we get a sound that is a bit duller than, you know, the dry sound. And the reason for that, and especially also the reason for why mixing with dry sounds a bit weird when there is no vibrato at all, is because in the oversampling that I implemented for this plugin, I'm using some filters that are not linear phase. Like you can see that there is oversampling 1x and oversampling 4x to choose from. And yeah, when you're choosing oversampling 4x, then it means that for the first upsampling and downsampling process, it uses linear phase filters that are very steep. But then for the next one, it just uses the infinite impulse response filters. They perform better, and that's why I chose them. The only problem is they change the sound a little bit. So in what way do these filters change the sound is the next question that you might ask. In order to find that out, I'm just instantiating EQ curve analyzer, and then I can see, okay, there is something going on. At the moment, it's a bit misleading though, because we have mix on 50-50, put it on 100%, and we see, okay, this is the response that we get. What I did to kind of compensate for this filter curve was, in a very low-key way, instantiated Pro Q2. And then I made myself a preset where I just came up with a curve that kind of compensates for the thing. And at the end of the spectrum, you can see that it fails a little bit. And also there's a slight dip in here. But the difference between the dry signal and this signal is like way below 1 decibel. So it's pretty much the same signal. Let's actually listen to this. And I can show you the difference by just wrapping Nel and Pro Q2 into a chain so that I can use the mix knob of that instead. As you can hear now, we have actually the same kind of sound on the 100% dry level. Of course, there is still the problem that 50% mix sounds a bit weird. But let's just disregard that for now, because it's not an easy problem to solve with the current setup, and instead just focus on this new advantage that we have, which is that, you know, that the 100% mix sound now sounds very nice, because that would be a nice thing to have in the plugin. Because I always find it a bit sad that even though oversampling the vibrato generally makes it sound much less grainy and is surely the recommended setting in this plugin, even though that is the case, it is also a bit sad that I always have to add Pro Q for it to be compensated to the normal sound again, and that kind of sucks. So what I'm going to do now is I will write down the settings that I have here in a separate file. Now every filter works a little bit differently. The values that I have in Pro Q will not mean that I use these exact values in any other filter, but it's still a good starting point, you know. We got basically all the information that we need. Now I can disable this plugin again, because unless something weird happens, I will not need it anymore. So now the next thing that I want to do is I start a new plugin project where I just implement this filter and I just put the parameter ranges to something that is close to these values, so I can really finally tweak them and maybe find an even better setting than I did with Pro Q2. Who knows, maybe I managed to do that. And once I have finally implemented this filter perfectly and found the exact values that I need for that specific filter, I can just take the code and put it into Nel, push the update, and then call it a day for now. At some point, I do want to come up with a new oversampler that solves both the problem of using too much CPU performance and preserving the sound. I know it's possible, a lot of other plugin developers can do that, so I will be able to do that as well. if I try really hard. But for now, I just want this problem to be more or less solved, because at the moment I'm working a lot with my plugin Nell when I'm mixing the music of Darian Geep, and I just want it to sound nice for now, no matter in which way I make it sound nice. So it's a good step for in between. So what I'm going to do now is I start a new project. It's going to be a basic plugin project for the Nell compensation filter, and it will have the DSP library as well. I will just create it on the desktop because I will not need the project anymore once I have finished it, and I think it's going to not take very long. So this is the stuff that it gives me. I haven't worked with the basic plugin preset for a long time now because I have my own framework that I slapped on top of Juice for making plugins. That's why they all looked so samey lately. But for now I will just use this thing. If I need anything from my other framework thing, then I will just copy it over in the process, because I don't think I need so much stuff right now, and maybe it would just take too long to have all that stuff to set up. Okay, I need to make sure to have copy step enabled, because I know that this is for some reason not the default setting, which kinda sucks. But apart from that, I should be pretty much ready to go now. Now you can pretty much see this as a tutorial on how to make a plugin in the easiest way in Juice, you know, disregarding everything that you don't need. And one thing that you definitely can do is start with the plugin editor, and just in your header, what you can do to make things really easy is just doing this, removing this, and then paint and resized, yeah, can also be removed, and this can also be removed. Yeah, this is P. Now audio processor editor wants to know about the processor, so you just make your initializer list here, and that should be pretty much it. And this needs to be a reference, okay. What am I even doing here, and why might be the question. Well, what I did here is make sure that I can delete all this. Now I could also delete the file if I wanted to, but I'm too lazy. Because I don't need this whole file for anything. I just make this a struct, and I don't even have to write public. And then, yeah, that's just my GUI now. And if I run this as a standalone, then it will just be an empty window that doesn't do anything. Oh yeah, I still have to set the size. Okay, now I have a plugin window. So now I can basically go here and remove this file, delete it, also move file to trash, and then hit ctrl-p, and it will have one file less, and it still works. Now in my processor, I will do the following thing. I go down here, and I know I want to have filters now. So what I'm going to do is AudioProcessor value tree state, APVTS. And I also know that I want to have a filter that will compensate for the problem that I have in Nell. So here's the API with all the Juice DSP stuff, and we can just look for a filter that would work. We have an FIR and an IIR class, and of course I'm searching for an IIR filter because they don't use much CPU and do the trick. And now I can just search for a filter that would kind of do something cool for us. I could get fancy now with the ladder filter and it would just add some drive to the sound. It would sound even better than before, and then I could call it analog warmth, but I could also just keep it clean. That's an option as well, and keeping it clean usually means using a state variable TPT filter, an IIR filter that can perform low band high pass. I need a shelf filter, so I cannot use this. Link width really filter designed to perform multiband separation. No, I don't use that. State variable filter, an IIR filter that can perform low band and high pass. Why no shelves? Where are all the shelf filters? After a lot of tedious searching, I found out where the filter is. Because apparently all the high level filters in Juice DSP do not have a high shelf, but you can just generate the coefficients for a high shelf like this. But apparently you need the sample rate, so I cannot do it in the constructor. So let's move it to prepare to play. So at least we already have the sample rate now. We want to play around with the cutoff, with the Q and with the gain as well. So it would be cool to actually have it in process block. Of course we can still not use it because we don't have parameters yet, but it will make sense, I guess. And after this we will have the filter, processing, the process context. But we see that process sample doesn't ask us for the channel. So apparently this filter needs us to instantiate actually two filters, one for each channel. So let's include array, SD array filter two filters, because now we can just loop through the channels. Okay, now I got the filter working, but I think the filter also wanted me to have to give it some prepare stuff, preparing it with a spec. Sample rate is sample rate, max block size is samples per block, num channels is get total num output channels, whatever, and then yeah, it should work. Let's just use the snap to zero feature for now. Later we might switch to the block processing way of things. Now what does this thing do? It returns a reference counted object pointer to juice DSP IIR coefficients. It's a long name for something. Reference counted object of juice DSP IIR coefficients load. Okay, now I have coefficients. Coefficients equals. Now how do I get the IIR filter to use the coefficients? Coefficients, so reference counted object. Just set that to the same coefficients. And this should not make a copy because it's just reference counted. And that's kind of the point of this whole thing. So I can just do this and it will not perform bad. However, this might just interfere with everything that's coming ahead. So I should make sure that it only changes the parameter values while changing the parameter. And that's just a mechanic that I can completely ignore later when I'm copying it to nil, because I will just use fixed values then. But for now it will be important, I think. We need a method for creating the parameter layout now. Creating the parameter layout for APVTS. Static. Okay, that looks good. So the method now exists, and what did it give me? Gain value. Let's use the range that we had. We want the gain value to be somewhere between 0 and 24, I guess, so that we can have something like 15.82, surely more than 6. Let's not make it stepped. What was the last argument? The default value. Let's just use the values for the default value that we have here. Okay. Okay, this looks pretty correct to me, even though I wouldn't have written it like this. So yeah, now we have parameters, I guess. So we can just remove the editor entirely. At this point, we could just delete this whole file, I think. I will not do that now. In that case, we would also have to return null pointer here. Now let's just get the cutoff, the gain, and the Q. Now we don't want to override the coefficients every time. So let's just keep some values here. And then ask if anything changed. Cut off is not cut off anymore. Or gain isn't gain anymore. Or Q is not Q anymore. Then they are being updated and then this happens. Now we need some default values for cutoff, gain and Q. Gain is currently on decibel scale. I think the IIR filter might ask for amplitude. Let's check. The gain is a scale factor that the high frequencies are multiplied by, so values greater than 1 will boost the high frequencies. Okay, yeah, great. That's exactly what I meant. So actually gain is juice, decibels, decibels to gain, gain. Oops, of course I mean this gain. This looks like it should pretty much do what it's supposed to do. The coefficients cannot be null pointer. Oh, that happens when you're trusting GitHub Copilot too much. Of course. Now let's try to run this again. Now something else of course doesn't work. Cutoff frequency has to be higher than 0 and lower than sample rate times 0.5, and that means that it cannot be over Nyquist, of course. So yeah, really not sure why FabFilter lets us go over Nyquist here, but it apparently doesn't make any sense in Juice. So let's just set this as the highest value possible and also the one that is used, and then it should be okay. Okay, great. Now we have a plugin that hopefully does what it should do, and we can try to run it in Bitwig to find good settings. Okay, so we have the situation that we had before where we just have null enabled, and then there is the frequency response, and then I can just instantiate the null compensation filter plugin. And something crazy happens which destroys the entire sound completely. Of course, why not? Okay, I understand why it happened. Frequency was still too close to Nyquist, but it doesn't really help. Can barely change the frequency response with these parameter values. Getting closer, getting closer. Look at that. What a nice match we got here. So now we finally got a high shelf that pretty much matches what's going on, and we can write down the values. For example, for gain, we got 14.435999999. Okay, to be honest, that is just 6. Now for frequency, we got 20k flat, and for Q, we got 0.229, and then we get this pretty nice looking response. Now let's just try to test how it actually sounds. Maybe it has audible artifacts or something. Nice. So it does sound perfectly like it should be. Now I can take the code and put it into Nell. So the next step is to actually open the project of Nell. First things I do is checking if I have the juce DSP module in it, which is the case. Yes, nice. I go to the place where I have the oversampler that I wrote, which is here. I do not want to mess with the oversampling class that I wrote directly though, because I really like how it turned out and don't wanna, mess with that now. But I will just use another struct. I will just call it oversampler with shelf, so that later I will see why I did that. And this thing just has a processor, and the processor is the processor of this namespace, and I just have to make sure that it has the same functions. Otherwise, let's just copy all the other stuff for now and see what we actually need. Okay, prepare to play just calls processors prepare to play. Now I can finally start with the fun stuff, which is copying this stuff from the filter over, instantiating all the stuff, and now in prepare to play, I can actually do this. And now num channels is now going to be 2, because I don't want to support people who use more than 2 channels at the same time anyway. Especially not in this plugin, it wouldn't make sense, because there is a mid-side feature, so there is no point in different channel layouts than 1 or 2 anyway. But we need to instantiate the coefficients before we set up the filter, because then the filter coefficients can be set to these coefficients. Now for these values I can just put here what I had before. For gain I have this magic number, for Q I have this magic number, and for frequency I have 20k. Now gain needs to be in actually gain values and not decibels, so it needs to be converted. In case that this is not the first prepare to play method, we also reset the filter. Looks alright to me. Now we have the upsampling stage and the downsampling stage, and I think what would make sense now is to just apply this to the downsampling. So we are downsampling the out buffer. The out buffer is the buffer where the stuff goes into, I think, and then we can loop through the channels and apply the filter. Now we have to figure out this whole block processing crap. Okay, so filter process wants to have a process context. So what the fuck is the process context? Context non-replacing or replacing? Okay, GitHub Copilot wants me to use context replacing. I guess that makes sense. This doesn't work because it wants me to use an audio block. Now this looks like it should work. We still have to replace the original processor, the original oversampler with the oversampler with shelf. Let's just try and see how it goes. Don't mind all the warnings, by the way. I have no idea where they come from, and it's an old project, so I shouldn't over obsess about the warnings. But just so you know, in my more recent projects I do care about the warnings a lot and try to get them out of my project as quickly as they appear. So now the moment of truth. We have Nell here. We add the EQ curve analyzer and we remove the compensation plugin and we check and we see it does the completely wrong thing. Great. Maybe it's the right direction, but it looks like it has way too much gain. So maybe that's a hint on what went wrong here. 7, I guess. Okay, that's like only slightly too low. So we know that the solution will be somewhere near to 7. Actually, it's kind of suspicious that here we have 14.436 and this is 7. I guess the solution is just to have this times this, maybe for some reason, I don't know. Okay, great. This looks pretty much like the response that we saw earlier. Let's test how that sounds. Great. So I guess that this video was good for multiple reasons, because first of all it showed you that if you're just stuck with certain DSP settings, then you can just get off your high horse and use some magic numbers to get stuff done. You don't always have to understand everything that's going on in a plugin. Even if you're creating it yourself, you just have to find a way to deal with it. And I found a way and it works pretty well. Of course, this logic only works if you're not working on something super serious like a mastering plugin, where it's extremely important that using dry wet is just working correctly. But for this vibrato, it is more like a long-term goal to get that done. And for now, I'm just happy that having it dialed in 100% gives me the same sound as 0% mix plus vibrato, of course. We also saw how to set up an extremely easy project for Juice, something that doesn't even require a GUI, has a basic parameter setup, pretty clean working with initializer lists and everything. And we also saw an easy example of setting up a shell filter, which doesn't seem to be the most generic thing ever in Juice. So it's good that there is a video out there now that has that, I guess. And we also saw how to integrate that into a bigger project with ease, just by wrapping some construct around another construct, giving it the same methods and just adding some stuff to the methods that already exist where needed, which is in this case just the prepare to play method that has the initialization of the filter and the downsampling method of the oversampler that is being called after the processing that comes after the upsampling. And then after downsampling the sound, I'm applying the filter. Okay, now the next step for me personally is I will push the new version of Nell to GitHub and also compile a release mode VST3 file for the Windows users. I'm still working on the Perlin noise mod to be a little bit better before I ask my Mac friends to also push a Mac version. Until then, Mac people just have to wait and Windows people can already enjoy the improved sound engine. Cheers.